BioCAM settings. In addition to the recording settings and modes that we have covered in previous videos, the BioCAM itself offers an array of features and settings to optimize data acquisition. Here we have opened a recording session, and we're going to open the recording settings panel in the controls window. In any recording mode, we can click directly on the BioCAM to open up the BioCAM settings. The BioCAM chip is sensitive to light. To avoid saturation in the presence of ambient light or direct light, the chip calibration rate can be changed from long to short. As we see here, long is ideal for dark to light conditions, whereas short is optimal for direct light and medium for daylight conditions. Here, our target sampling rate by default is set to 18,000 Hz. This default sampling frequency favors high frequency of oscillations for spike detection. To optimize the BioCAM for detecting LFPs, which are slow frequency oscillations, the frequency can be set to 9,000 Hz by clicking on the drop-down menu and selecting 9,000. Below, we see the effective sampling rate. In addition to the online and offline data filtering options that we have discussed in previous videos, we also have the option to add a high-pass filter directly to the BioCAM. In effect, this filters data at the hardware level, and setting the correct frequency value is key to obtaining your targeted raw data results. As per the target sampling rate, the high-pass filter cutoff frequency default value is set to optimize spike detection. In order to enhance the sensitivity of low oscillations to record local field potentials, set this filter to a low value, like 1 Hz or 0.5 Hz. Underneath, we have the I/O signals. Here, we can change the values for the internal chip calibration. These are enabled by default, meaning that the output channel, which is currently set to 1-1, will not record data, but rather will show when the chip is recalibrated. This option can be disabled by clicking No. And when enabled, the output channel can also be changed by clicking on the drop-down menu. In addition to the internal chip calibration, we can also show other signals, like the internal stimulation that we have discussed in previous videos. Once this internal stimulation is enabled, the output channel, in this case 1-2, will not be collecting raw data, but will instead show when a stimulation is triggered. We can also use the analog inputs 1 and 2 that are on the BioCAM to monitor the triggers of connected instruments, for instance an external light source. Once these settings are enabled, we can select our output channel and set if we wish to recalibrate the chip after each trigger, and set the calibration delay. This is effective for recalibrating the chip after each light trigger. The settings are similar for the analog input too. Additionally, we can choose whether to collect data from the full array of microelectrodes on the chip or to choose a subset. By default, the full array is enabled. By clicking Array Subset, we can use the selection tools to click and drag on the area that we wish to record. Additionally, here we see all of our selection tools available, and we can make multiple selections that are not contiguous. By holding down Ctrl-Shift and clicking and dragging, we have made another selection. Here we see the total number of channels that we'll be recording. Once we have configured our settings, we can click OK. Here we see that the live FMEA viewer has changed to represent the recording channels. Now we can click play to begin acquiring data and record. To check our BioCAM settings at a quick glance, we can also use the Source BioCAM window by clicking on the gear icon to open the settings panel. Here we see the most important settings and can conveniently adjust them from here, like the target sampling rate, the high-pass filter cutoff frequency, and the I/O signals.